Greetings to you, ladies and gentlemen. Welcome to Shakes's YouTube channel. Um, Today we are going to talk about physical computing architecture and analog to digital conversion and digital signal conversion to analog. So that's what we're going to talk about today. We are not going to waste much of our time, but I'll just show you some illustrations and some animations that I think are going to be of much or great help to you. So the physical computing and IoT module, that's what we are learning, and I encourage you to motivate me through liking the stuff that I upload on my YouTube channel. Please comment, give a comment. Your comments come as building pillars. They help me in modifying things that I need to improve. They come in form of suggestions. Some they seem to be negative, but negative things build positive things. So that's what I think. So your comments are always welcome. Ask your questions in the comment section. Uh, give your suggestions and contributions. Maybe my explanations may need actually your contribution for somebody to get it. Maybe you are the one with the message for someone to understand what I'm trying to convey to you guys. Then learn to share, learn to share. So you have to share this content with your colleagues or whoever you think is um, supposed to get the message that I'm sharing with this video content. And then most importantly, subscribe to this YouTube channel so that you don't miss out any new video that I'm going to upload on this channel. I hope everything that I upload on this channel is helping somebody to change lives in the real world where we are living, facing challenges, facing problems that are drawing us or pulling us back. So let's not get into today's business. We've talked about this computing unity or the physical computing, where we talked about the central processing unity and all its contents, maybe the basic contents of this central processing unity with the animation as you can see. But today I just gave you this as a recap so that you can look at it and get an understanding on how computers really work. They get input into the central processing unity, and then the control unity having all the rights to accept input, put it in memory, direct it to the ALU, which is the arithmetic logic unity, or direct it to the secondary storage, or forward it to or relay it out to the output devices. So this is generally the central processing unit, which is on each and every uh, smart device, including mobile phones, tablets, computers, laptops, desktops, supercomputers, and all computing devices such as the microcontrollers, which we are going to talk about mostly since we are talking about processing, controlling embedded systems and stuff and stuff. So without wasting much of your time, you have seen this animation and I've described it, explained it, illustrated it, and I'm not going to waste much of our time. We'll talk more about the computing unity. So when we look at a computer, this unity that we are seeing here is just the unity that process everything. Although we have other processing devices, we have a CPU as the central processing device or central processing unit, which accept the processing of visuals, arithmetic, logic, comparisons, um, categorical data analysis and stuff and stuff. But when we want to specialize, we pick the specific processing device that work on something. For instance, if we want to deal with sound, we have sound card. Let me just end here. We have a lecture for those processing devices. But for today, we're going to look at the physical computing device or physical computing unit. So what happens is we have the real world that sends signal to a digital device that process data in a digital number system or in a digital manner. So in a digital manner, we are talking about zeros and ones being the digital signal. But the real world, like the sound that we are hearing, the visuals that we are seeing, all these are the analog signals. So that's where the input is. And we've talked about the physical environments. The physical environments are the ones that generate the analog signal that we need to accept in a digital processing unity. And then the digital processing unity accept it, but it needs to convert it, if it's analog, convert it to digital so that it becomes compatible with the system and it becomes easy for the system to do the computations. Once we are done with the computations, we then make a decision to say, do we want to output the analog or do we want to output it as digital? So we have to accept two types of signals. The first one being digital, the second one being the analog. So the real world mostly it produces analog signal. For example, I've given you an example of sound. We can talk of weight, we can talk of temperature, we can talk of liters, the amount of water in a container, the amount of fuel in a vehicle tank. All these are what we are saying analog signals. But digital signals are just zeros and ones. So those values, let's just say we are reading room temperature of 36 degrees Celsius. So 36 is a decimal value. We need to convert this value to digital. So that's how the computer deals with the analog values and convert it to digital and do the processing. So today I'm going to show you the architecture itself first, and then we talk about how the data flow from input up until we get to the output. So we have the input, and then the next thing is the controller board. Here I'm just talking about the system that you custom make, the system that is custom made by the programmer, the engineer, so that you come up with your own system. So normally we come up with controller boards, or the controller board is the one that is housing, let me just term it as a microcontroller, which contains all the components of a computer, and we may term it as a mini computer, which focus and concentrate on one goal. Right? So the controller board or the control unity, which is the one that does the processing. This is the controller board or the control unit or the computing unity in my own terms. This unit normally accepts digital signals. So digital signals are going to be represented by pins that are in the color blue. As you can see here at the bottom left corner, we have our blue input pins. So each pin we are having 1, 2, 3, 4 input pins, which are digital. But we also need to accept analog signals. So analog signals are represented by that color, and at the top left corner of this controller board or control unit or physical computing device. And then the other thing is when we input something, definitely we need to output it. Like we eat things, we eat stuff, we need to output it. So that's the same way computers are designed. They input something, digest it, give output. So this is how the system is doing. So sometimes you eat something that you cannot digest. You can give it out as it is. Sometimes you eat something and you digest it, you output something that is totally different. So that's how computers do at the same time. That's what the computers do as well. Right. So they input digital, they also output digital. They input analog, they can also output analog signal. So it depends with what you want to input to the computer. So what you can input and what do you want to process, how do you want it to be processed, how do you want it to be outputted. So that's the engineer's decision, which then the computing node, when I say the computing node, I'm referring to this device which is having the input and the output pins. So we connect our input sensors, our input devices to the input pins. So in this case, we're having digital input pin and analog input pin. So when you are getting digital input, you connect your sensor or your input device to a digital input pin. Get me correct here. If you are inputting analog signal, you have to connect analog input device to analog pin, input pin. Right. So we also have other devices, smaller devices. So that's why we call a microcontroller a compact device, because it has got all other components that we need integrated in it. So other components that we have, of course, we need output connected to either analog output or digital output pins. The other thing that we have is the microprocessor. The microprocessor is the one that we have talked about in the previous lecture and in the previous slide as a recap. So we have the microprocessor. Here I've termed it as the processor. So this processor could be sound processor, visual processor, arithmetic and logic processor, or any other processing device that is integrated into this computing unit or device, or maybe not. We also have analog to digital converter. Mostly it is integrated in the controller board, but sometimes you may find it as an external device, which is not inside. But in this case, as I'm describing and illustrating to you here, it is inside the controller board, or it is part of the circuit board of our controller board. And then we also have digital to analog converter. So we need to accept values from the real world. Since the real world produce analog signals, we need to have such signal get in and then be converted. Then we get it to the processor. The processor does what it does and gives output through the output pins. So with this, let's now start to talk about inputting digital values. So when you input digital values, what happens is you connect the the input devices that gives digital signal. You connect them to the digital input pin. Once that is done, the signal is then transferred from the input devices to the input pin through the microprocessor or the processing device that is connected or integrated inside the controller board or the control unit or the microcontroller or the computing device. So then what happens next is we may need to output the digital signal as it is without converting it to analog or without converting it to digital. Right. So that's how the signal is processed. It gets into the computing device through the input pins, goes to the processor, goes to the output device, gives you the output. There is now two-way communication between the user and the computing device. So this is the same way the data is going to flow from input to output. But it differs because sometimes we input digital signals, which I said are in blue. Then they go to the processor, but sometimes we need to output analog signals. We need to output analog signals. So the processed digital signal is then sent to the digital to analog converter. So this digital to analog converter then converts this signal to analog and send it to output devices through the analog output pins or output ports. So that's how we accept digital input, process it, and give output. But all these processes, you may not actually observe it unless you need customized, custom processing pipeline. And then sometimes we, like I said, the real world produces analog signal and we accept it as input, as you can see from the uh, illustration. We accept analog input through analog pin. Then analog takes the values into the analog to digital converter. Then the signal converted to digital is now sent to the processing unit. Since the processing unit only understands zeros and ones being the digital signal. Then once we have converted that, we can convert it back to analog since we need analog output. And this analog output is then sent to the output devices through the analog pin or analog ports. Sometimes we may say we are accepting real world signals that are analog, but we need to output digital signals. So this happens this way. We accept our real world analog signals, we convert it to digital for processing. Once processing is done, we send the signals to output pins. The output pins convey the message to the output devices. So that's how we accept signals from the real world, signals from other digital devices, process it, do the conversions, give output. So that's how the computers communicate with human beings. That's how computers understand what humans understand. The processor being the brain of this computing device. So at the moment, I think we've covered the architecture or the computing architecture. If I've left some other items, share in the comment section so that we can get help. If I missed something, help me in the comment section. Thank you very much for paying attention. Like Engineer Sheikh Martin's page, comment, share, and don't forget to subscribe. If you've subscribed already, be blessed by the Almighty God. Enjoy the rest of your day. Be blessed in whatever that you're doing. Goodbye.